guys, how's it going? So welcome back to primaEd. Okay, so today we're going to do this vector question. This question is very interesting. Okay, it's one of the most interesting questions that I've seen in our ZIMSEC exams. Okay, and I want you to follow through. If you follow through, there's a chance that maybe a question on vector you'll be able to ace it, and you'll be able to do well in your exam. But essentially, the way that I want you to follow through is to actually grab a pen and a paper and follow through with me on this one. Okay, what you do is just draw the diagram, because what's going to happen is that I'm going to flip to other slides as well, and then we won't be able to see the answers and the questions from previous exam. Okay, I will try to write just the answers that we're going to carry them, but then just having the diagram handy, it will go a long way. So just grab a piece of paper and then just write this information here, and then we start. Okay, so the first thing that you notice here is they actually ask for OX in the uh, paper that I got, but this one it was certainly a typo, in the same sense that P here was a typo, because we were not told of any P here. This one, it's actually supposed to be N. Okay, so you are told that N lies on AB. Okay, so sometimes it's very rare that ZIMSEC makes mistakes. I don't know if somebody who was transcribing this paper was the one who made the mistake, but essentially that's the purpose for the decoder. You read the decoder and see if the information goes hand in hand with what's written in your diagram. And also here, the way that I was able to reason out that this must not be OX is that the way they ask questions is very predictable. So here they ask you AB just because you'll be using it to find AN, just like that, in that order. Okay, so without further ado, let's just jump right into it. So here you're asked to find AB. You're told this information. This information, it's essentially what you're seeing here. ABO, it's this massive triangle here, and within it you find some other triangles, and then these triangles they're made in such a way that some of the sides, they also correspond according to a certain ratio. So for example, AN, just like I told you that this one was supposed to be N. Okay, so this one was supposed to be N. So here AN, it's equal to 1/5 of AB. So this one, it's only a fifth. And this shows you that, they never used a scale to actually draw some of those things. Okay, so this one was supposed to be one part in every 5 parts. Okay, so it was supposed to be just a fifth, but then they didn't do that, just because they are not really adhering to any scale. Okay, so here you're asked to find AB. So AB, how do you find AB? The first thing that you do is identify what path to use. So most of the times you have to use path that the paths that are kind of populated for you. So here you have A, here you have B for OB. So obviously the path that you're going to take from A to B must be A to O first. Okay, so you're going to get from A to O first, and then from O you're going to get to B. Okay, so just identify the path that you'll be taking. You could have said maybe A to X, X to N, N to B. It's still fine, you'd get the same answer. But then the problem is that here you don't have any values, so there is a sense in which you have to be very strategic with how you're arriving at the desired vector. Okay, you want AB, just go from A to O first, and from O to B. Okay, so you can even identify AO, then OB, A to O, then O to B. Okay, so here AO, it's negative here. Okay, I always use this diagram because it helps me out. I'm just getting from A, I'm going to O, I'm going against this arrow here, so it has to be negative, and then that's it. And then OB, it's positive, so it's just like this. Okay, so this is what you get. And AN, so AN is equal to, so A to N. Now you're getting from A to N. You can use this decoder here. Okay, so you're told that it's equal to 1/5 AB, like this. So 1/5 your AB, it's equal to negative A plus B. So there's a sense in which most of the times these questions, they actually go hand in hand. Okay, so most of the times they actually go hand in hand. The answer that you got previously is the answer that you carry forward to the next. It's kind of a key to the next part. Okay, so always remember that. So what I'm going to do here is I'm going to write down my values here so that we don't forget them. So a, b. Okay, so it's actually cut out a bit. So a, b is equal to negative a plus b, like this. And a n, so I'm going to put a semicolon here, and a n, it's equal to, you realize that we'll need these answers, at least some of them. That's why we have to note them down somewhere. If you are in an exam, you're just doing this on a single piece of paper, so that should be fine. Okay, so you don't have to note down anything. So the part item 3, you're asked to find on. So on, again, you see you actually have to use an here. So o to n, we had said this is n here. So let me actually emphasize it so that we don't have to continue writing it. So on is equal to, so you want to go from o to n. So you already have an here, so which makes this one a very attractive path of going from o to a first. So you're going from o to a, and then you're going from a to n. Okay. And the massive thing, the beautiful thing is that you already have an here. So OA, it's equal to a. This time we'll be going in the direction of our vector, which is a very good thing. So plus an. An is this one here, which we got from here. Okay, so it's negative 1/5 a plus 1/5 b, like this. So 1 minus 1/5, it's essentially 5/5 minus 1/5, you get 4/5 here. Okay, so 5/5 a, then plus 1/5 b, like this. Okay, so this is it. You're done with this part. And am, you asked to find am. Again, you have to choose what part to use. Okay, so am is equal to, the easiest path is to go from a to o first, and then you go from o to m. Okay, so a to o. So let me just rub this. I don't know why I repeated that. So a to o, it's negative a. Okay, so, and then from o to m, you're told that m is the midpoint of ob, so it's obviously half ob. Okay, if you want, you can write like this, and then you go on to substitute what's ob for you. So ob is equal to b. Okay, so this one will be your answer. So we're going to record our answers once more so that we use them in later parts. So on is equal to 4/5a plus 1/5b, like this. Okay, and then the next one is am, it's equal to negative a plus 1/2b. Okay, so this is good. Let's quickly wrap, and then we move to the next part. The next part now is you're told, so I actually want us to rub this one as well because we don't need it. So the next part, you're actually told that it's given ax is equal to ham. Okay, so now you're given ax is equal to ham. So already you have am here, so you want to express ox in terms of this. Okay, so you have am here. What we're going to do is we're going to substitute am. That's why I told you, if you want to score very well in vectors, especially those long form vectors for paper 2, you have to understand that they kind of interlink the questions. They're kind of interlinked. Okay, so half hb, like this. Okay, so this one would be your ax, but you want ox. So here what you notice is that this one is in terms of h, so obviously they're using the path with ax. So ox would be, you go from o to a first, then you go from a to x. The reason I could write this without looking at the diagram is that I know that I'm supposed to use ax here, because ax is the order for h, as we ax is the order for h, as we did here. Okay, so in order for me to go using ax, for me to go from o to x, I have to go from o to a first, and then I have to go from a to x. So from O to A, just look at your diagram, it's supposed to be A. Okay, then from A to X it's what you're given here. So you're now substituting. So this is half HB like this. Okay, so here you can arrange like terms, so it'd be HA here plus half HB like this. Okay, so here you get A. If you want, since A is the vector, you have to put it at the end. Okay, so 1 minus H, you're factoring out A here, and then this one is simply half HB. Okay, so this is it, and you can say shown because they want you to show it. So now you've shown them. Okay, so let's actually record our answer just like we did the last time. So we have OX equal to 1 minus HA plus half HB. Okay, so let's quickly rub, and once we rub, we move over to the next part. So if OX is equal to KON, so we're given another condition again, and we asked you if OX here it's equal to KON, we're given another condition. Okay, so let's first substitute ON here so that we get our expression in terms of actual vectors. Okay, so ON you're given here, it's 4 over 5A plus 1 over 5B like this. Okay, so which is good. So here you get 4 over 5A, okay, KA plus 1 over 5 KB like this. Okay, so this is it. And remember, you also had OX equal to 1 minus H, you can even say from B. Okay, so 1 minus HA plus half HB like this. Okay, so what you're going to do is that vectors, these components, they're always independent. Okay, they're perpendicular and they're independent. They're perpendicular and they're independent in terms of Cartesians. So these components, they're always independent. They are independent in general. Okay, so they must be the same. The components must be the same. So the A component, the component of A and the component of A here must be the same. So you say by comparing A components. Okay, so you can even start by comparing A components, or you can start by comparing B components. It's still fine. Okay, so by comparing A components, you get 4 over 5 K here, that's equal to 1 minus H like this. Okay, so by comparing B components, okay, or you can say B component or B vectors, B components, still fine. So here it should be 1 over 5 K equal to 1 over 2B like this. Okay, 1 over 2H, I mean, because you're comparing, this one is 1 over 5K, this one is 1 over 2H, which is fine. Okay, so what you get here is that K is equal to 5 over 2H. Okay, when you multiply both sides by 5. So you can actually go back here and substitute 4 over 5 here, sorry, 4 over 5 here, and then K, it's 5 over 2 here. Okay, so H, you're substituting on K, equal to 1 minus H like this. So here you cancel, here you get 2. Okay, so you get 2H equal to 1 minus H. You get 3H equal to 1, H equal to 1/3 like this. Okay, so you get H equal to 1/3. After getting H equal to 1/3, you say from, because you have to find the value of K as well. So 5 over 2H. Okay, so K equal to 5 over 2 by 1 over 3 here. So 5 over 2 by 1 over 3, what do you get? You get 5 over 6. Okay, so this is it. We're going to record our answers as well, yeah, in case we need them. Okay, so H equal to 1 over 3 and K equal to 5 over 6. Okay, so we had recorded this one, and so let's also record this one here, that OX is equal to, but then this one might not be necessary. Okay, let's just record it in case we need it, plus 1 over 5 kb, like this. Okay, so that's it. Let's wipe. So the last part asks us to use the results from B to C to calculate the numerical value of H and K, which we just did here. Okay, we found H equal to a third and K equal to 5 over 6, and then you're asked hence or otherwise find the ratio of the area of the triangle OAX to area of triangle OAM. Okay, so triangle OAX to triangle OAM. So to get the area, so you're asked to find the ratio of the area. So ratio, let me just something real quick. So you're asked to find the ratio of area. Okay, so area of triangle OAX over area of triangle OAM, like this. Okay, so this is what we're supposed to get the ratio. So what you notice here is triangle OAX, and so triangle OAX would be this triangle here. Okay, so what you notice is that this triangle here, it shares this triangle here, it actually shares the same angle with this triangle here. Okay, so which is a very good thing there. Okay, so they actually share the same angle, and this angle it's this one here. Okay, so let's call it theta. So if you're to write the area of our triangle OAX in terms of this angle here, you'd be writing it as half. Then you need the side here, you need the length only, so half OA. Okay, so half OA, this side. So we will take the side that are sandwiching the angle. Okay, so AX multiplied by sine theta. This is simply half AB sine theta, the formula that we used to find the area of a triangle. Okay, so and then for this one it'd be half, again OA, because it's this limb here and also this other limb here, multiplied by AM here, multiplied by sine theta. Okay, so what you notice immediately is that some of these elements here, they actually cancel out. So here this one cancels, here one cancels, this one cancels, and then others they cancel. Okay, so the interesting thing that I want to show you now is that let me show you, so it will be a bit crazy, but here notice that AX is equal to HAM. So you can actually substitute HAM here, so it actually be HAM, so you can actually write HAM here. Okay, so to represent AX would be HAM here over, and then you have AM here. Okay, so from here you can actually cancel those ones as well, and then your value of H you had gotten is 1 over 3. So the ratio, therefore the ratio of the area of triangle OAX to the area of triangle OAM is equal to 1/3, and then that's it. Okay, so this was really tough, but then it was also interesting, and I hope that you kind of do it as well. So what I want you to do is, if you didn't get it right the first time just going through with me, what you do is you just go back to the start of the video after a day or so, and then you see whether you're grasping the concepts. And then if you have any part that you didn't understand, obviously you can leave the questions in the comment section. So this was really interesting. We'll continue with our paper in the later days. Okay, so thanks so much for watching. Make sure you like, share, and subscribe. Yuba out. Cheers.